everyone, and welcome back. My name is Mr. Cobalt, and in this video, I'm going to go over how to use the ideal gas equation. In part one of the video, like in part one, I went over one way of doing this particular problem using P v equals nRT in its normal form. In this video, part two, I'm going to show the same problem, but we're going to use a slightly different equation that we derive from this one, using the information they give us. So if we recognize here that we've got grams here, we can use a form that allows us to use the molar mass along with the mass in the equation. So we don't have to do, we can do one less conversion. However, we still have to convert milliliters to liters, and we still have to convert the millimeters of mercury to atmospheres because our R value, the ideal gas law constant, has those units in the constant. So we're going to keep these two since we did that conversion last time. But what version of this equation am I referring to? Well, if we are given the mass, and we'll say the mass in grams, right? So M, or we could use G for the mass in grams, right? Which is what we have here. We have it as M. So this is 0.0421 grams. So G, the mass in grams. And we can find the molar mass of the substance, in this case, the argon. So the argon, the molar mass, we'll say that's like a capital M, right? So we'll say a capital M is the molar mass, and the molar mass of argon, and we said that the molar mass of argon was 39.9, let me double check again, 39.95, and that's grams per mole. Okay, so if we have these two, then if we remember the relationship between this and moles is that N, the number of moles is equal to the mass in grams divided by the molar mass. So G over N. So if the number of moles, N, is equal to this mass in grams over molar mass, then we can replace that, substitute that in for this, right? So then we get PV is equal to, instead of nRT, we're gonna replace N with G over N. So it's gonna be G over M multiplied by RT. So then we have RT. So now we have that version of the equation. So all we have to do is solve for the missing part. Again, temperature. So if we solve for temperature, right, or we could just plug things in and then solve for temperature. It's up to you. So again, if I solve for temperature, all I need to do is divide both sides by G over M and R, and then divide this by G over M, the molar mass, times R. So then this cancels out and I get T is equal to this, right? Or if I manipulate this a little bit, then I have T, right? Dividing by a ratio or a fraction, G over M, is the same as multiplying by its reciprocal. So I can multiply by G over M. So T then becomes, M goes on top. So that's going to be equal to the molar mass times the pressure times the volume. And that's going to be divided by R. So R is on the bottom with G being the mass in grams. So that's the equation. solved for temperature. So now all I need to do is plug in the information here and here. So the molar mass we said is 39. So this is going to be equal to 39.95 grams per mole. Okay, multiplied by pressure, which is this number here. So that's going to be, oops, here, let me bring this down so I have space. So we'll write it down here. So the molar mass is 39.95 grams per mole. Grams per mole. And that's going to be multiplied by the pressure, which is in atmospheres. So that's going to be 1.252, and then a line under the 5, so we remember. 63 atmospheres. And I have the line under the 5 because when I did my conversion, I need to remember that the number of sig figs I'm allowed to have is 3. So I put a line under here so I remember that I have 1, 2, and 5. So I stop at the 5 when I'm trying to figure out the sig figs of my final answer. I'm going to use more digits. You always want to use at least 1 digit more than required. So that way you avoid rounding errors in your answer. So that's the pressure, and then the volume is this here. So I'm going to add the volume. So I'm going to multiply 0.0230 liters. And now I'm going to divide by G and R, G being the mass in grams, which is 0.0421. So 0.0421 grams, and then by R, that's multiplied by R. So in this case, we're using the 0.082058. So 0.082058. And the units for this form or this number of your R value is going to be liter atmospheres over Kelvin mole. All right, so let's see what cancels out. So we have moles here. Moles cancels out with moles down on the bottom. Grams on top can cancel out with grams on the bottom. Atmospheres cancels out with atmospheres on the bottom. And liters cancels out with liters on the bottom. And so everything cancels out except for Kelvin, which is what we want because we're looking for a temperature. So when we calculate this out, we get, I'll write the answer up here, we get 333 Kelvin, just like we did before. And again, if you subtract out 273, then you get 60 degrees Celsius. So this is your answer. And again, just go over the sig figs. If you are interested in sig figs, this has 3 sig figs because when you multiply and divide, your answer should have the same number of sig figs as the least number of sig figs in your measurements. So this has 4. This has, oops. Sorry about that. Okay, so remember, your answer when you're multiplying and dividing should have the same number of sig figs as the least number of sig figs in your measurements. This has 4. This has 1, 2, 3. This one has 5. This one has 1, 2, 3. I stop at the 5 because it's underlined. So 1, 2, 3. and then here 1, 2, 3. So the least number is 3, so that's why I have three sig figs here. Now you may be wondering about the 60. Well, that doesn't have 3 sig figs, Mr. Cobalt. Well, what's going on there? Well, notice that I got the 60 here because I subtracted 273 to get the degrees Celsius. Well, that's a different rule because you're subtracting, right? And the rule for subtracting or subtraction and addition is that your answer here is 60. My answer here should have the same number of decimal places, not sig figs. Should have the same number of decimal places as the least number in the measurements that I was subtracting, right? So here, this here has no decimal places. So the last digit is the ones place. Here, the last digit is the ones place. So that means that my last digit should be in the ones place, and it is. So 60 degrees Celsius. That's it for this video. I hope you enjoyed it. This was the second method of solving this problem. So again, there's two methods. You could just use this form of the equation, or you could use this form of the equation. Where's my original form here? So the PV equals G over M times RT. So that form is available as well. So if you remember that form, anytime you're given a mass and you know the identity of the substance, so you can find the molar mass, then you can use this form of the equation. So that's it for this video. If you like the video, if you learned something from this video, then please by all means like the video, share the video, hit that like button. Also make sure that you subscribe to my channel, and when you do, make sure that you click the button, the notification button, and click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you want me to go over for you and help you out with, or if you have a topic you want me to cover, I would love to do that for you. Thanks for joining me, and have a great day.